All right, seventh graders, you're on deck. It's first day of school, and don't know if we're going to be doing anything or not, but around these parts, I'm going to help you tackle that dreaded F word, this time on Math Matters. What's good, everyone? Ty the teacher back at it after a little hiatus to kind of get my mind right. Nothing like a birthday yesterday to close a few chapters and to open up a few new chapters. Like in this thing going, it's coinciding with you all's first day of school. Don't know if you need it for today, but you will soon enough. So my F word is future. Your F word, seventh graders, is fractions. The standard today, it's the second one, is for you to be able to recognize and generate representations of rational numbers, including equivalent fractions. Now, not going to dive into rational numbers too much, or matter of fact, at all, because it's in the preceding video in this playlist for seventh graders. The video is called Numbers in a Box, and it explains rational numbers quite thoroughly, so no need for me to uh, binge on that. So, what we'll do is go to the board here and explain what a fraction is. And usually I like the definitions to be brief. Brevity is a must around here, and it's up there in red. A fraction, seventh graders, is just a division problem. It's the top number, which is called the numerator, divided by the bottom number, which is the denominator. And in most fractions, especially all proper fractions, the top number is smaller than the bottom number. So if you look at the two fractions I have written down, 1 divided by 2, that's $1 divided by 2 people, or $7 divided amongst 15 people. Now, if you think about it real hard, you can kind of know what at least the first number is. First number is 0. Because if 2 people are sharing one thing, they're not getting one thing each. They're getting 0.5 or half a thing. Same thing with 7 out of 15. If you have an improper fraction, then the number on top is bigger than the number on the bottom. So if you just flip around the top fraction there, 1/2, and make it quite simply 2 over 1, then that's $2 for one person. 2 divided by 1, we know is 2. So we're dealing with proper fractions here because we're going to make them rational numbers. And remember, rational number can be either a decimal or a percent, but we're going to harp on the fraction end of it. It's another lesson in the sixth grade camp called FDP, fractions, decimals, and percents. And I'm sure that's going to be coming up later. So I'm not going to harp on the decimals or the percents. We're just going to work on fractions and show you how to create equivalent fractions and then how to see if two fractions are indeed equivalent. You will need a calculator until you don't, because you're going to divide the top number by the bottom number, and again, these are going to be proper fractions. Since the top number is going to be smaller than the bottom number, the answer is going to be 0 decimal numbers. So it's not, the number is going to be smaller than 1 but bigger than 0. So if not quite comfortable with long division or dividing a small number by a big number, then have a calculator handy until you can pick up on the patterns and decimals. Again, math, spot patterns, and I'll show you a couple here. So for starters, we have 1/2. Again, that's $1 or one thing divided amongst two people. So for them to get an equal amount, they will have to split or cut in half that one thing, obviously. Now, how can we make this fraction 1/2 an equivalent fraction? How can we make an equivalent fraction out of 1/2? The ironic thing to that process is even though, and that's what we're doing now, how to make any equivalent fraction. Even though fractions are division problems, if you want to make an equivalent fraction, you're going to have to do the opposite of that. You're going to have to multiply. And you're going to have to multiply by 1. And I'm going to put that 1 in quotation marks because these are going to be the funniest looking ones you've ever seen. It is going to be a fraction. Now, I'm not going to draw the x for multiplication anymore. By the time you get to 8th grade, you need to know that x is used in algebra ad nauseum. So if you want to multiply something from now on, you're going to put one or both of the numbers in parentheses. It doesn't matter if you use 1, and I'm just going to use 1 here, but parentheses is going to be multiplication from here on out. So we're going to multiply by 1, but since we have a fraction, we're not going to take this and multiply it by 1 because it would literally be 1/2. We're going to multiply it by a weird looking one, and that is quite simply, there's a rule here that says any number, we're going to name that number P, any number divided by itself is 1. So think about that for a minute, 7th graders. If you had $6 for 6 people, all right, $6, the numerator, for 6 people is the denominator, they would each get $1 each. If you had $1 for one person, that one person would get $1. If you had $23 for 23 people, and again, division is sharing equally, each person would have $1. So that's the kind of one you're going to multiply by this 1/2 by. Let's start small here and go 2/2. All right. So multiplying fractions, and believe it or not, out of all the things in your math world this year, multiplying fractions is the easiest thing. It's like how you want to add fractions, which is incorrect. You just go straight across the numerators and the denominators. So here, 1 times 2 is 2. 2 times 2 is 4. And for all my sports players, you know that 2 out of 4 is indeed 1/2. Right? You can even multiply this times another one. Let's multiply it by 4/4. I know I'm saying the number 4. That's not 1, but 4 donuts for 4 people, they would each get 1 apiece. So let's multiply straight across here. 2 times 4 is 8. 4 times 4 is 16. I believe if you had 2 8s, you would have 16. So that is an equivalent fraction. And use your calculator if you want to. 1 divided by 2, 2 divided by 4, 8 divided by 16. Let's do a couple more. We're going to multiply that by another one here. 3/3. 8 times 3 is 24. 16 times 3 is 48. If 16 is double 8, and we're multiplying both numbers times 3, then 16 times 3 has to be double 8 times 3. And 16 times 3 is double 8 times 3. It's 48. That is an 8. And 24 out of 48 is half. If you were to put any of these 3 underlying fractions in a calculator, it would read 0.5. And that's it. So 1/2, 2/4, 8/16, 24, 48, they're all 1/2. The thing is, if you had this as an answer, us as math teachers aren't going to count that as correct because both of the numbers in the fraction, 24 and 48, have a common number you can multiply to get them. 24 and 48 both have common numbers you can multiply by to get them. So what we're going to do is kind of decompose that fraction there. And we'll do that by trying to find the factors of 24. Well, we know 24 is 12 times 2. And I know 12 is 4 times 3. And I know 4 is 2 times 2. We got 1, 2, 3 2's and a 3. So 24 is 2 times 2 times 2 times 3. 48 is 16 times 3. We just saw that there, yeah. 16 is 4 times 4, and 4 is 2 times 2. We're going to do that 2 times. So down here we have 2 times 2, that's 4, times 2 times 2, that's 4. 4 times 4 is 16, times 3. Now, this is a decomposed way of writing 24 over 48. And in a fraction where you've done this, where you've broken the numbers down into the numbers you multiply to get it, you can cross out any number that's shared on the top numerator and bottom denominator, like so. You got a 2 on the top, 2 on the bottom, get rid of them. Got another 2 on the top, another 2 on the bottom, get rid of them. Yet another 2 on the top and a 2 on the bottom, get rid of them. Got a 3 on the top and a 3 on the bottom, get rid of them. Well, we've got rid of all 4 of these numbers. So what do we put up there? We put up there what 2 divided by 2 is. Quite simply, 1. So when we decompose that, all the numbers are gone. That means you throw in a 1. And the only number that was saved is this 2 right here. And there we go. Back to the original fraction, 1/2. Now, decomposing the numbers to the factors, that's the little step up if you can do that. I'm just going to tell you again that if you have an answer, that's a fraction, and the answer in this case is 24 over 48, that answer is not correct because both of these two numbers, 24 and 48, share a bunch of factors. They share 2 times 2 times 2 times 3, which is 24. And that makes sense. 24 divided by 24, and 48 divided by 24 is 2. Now, so that's just a little stretching out of that. Just get ready to put fraction answers in lowest terms. So let's try this difficult one down here. 7 over 15. We're going to do the exact same thing. Let's just multiply it by 1, but a funky looking 1. All right. 7 times 2 is 14. 15 times 2 is 30. Bingo, bingo, bongo. Do that one again. Let's multiply it by 10 over 10, which is still 1. And if you have a number and you're multiplying it by 10, we have a number right here, 14, and 30. We got two numbers. And multiply both by 10. You literally don't have to do any math to get that. If you multiply a number times 10, just put a 0 in back of it. And 7 over 15 is 14 over 30 is 140 over 300. You can keep adding zeros here as long as you do it to the top and bottom, and it stays equivalent. So that's equivalent fractions here. You just multiply it by 1, but that 1 has to be a fraction, and there's a great rule out there that says any number to your heart's content. Obviously, I don't want to throw odd or weird numbers out there, but any number multiplied by divided by itself is 1. You want to multiply this times 38 over 38? Well, good luck with that, and you can do it, but the answer is still equivalent to 7 over 15. And of course, like this 1/2 fraction, if we were to turn this into the multiples of 1400 and 3000, it would bust all the way down to 7 over 15. So, that's being the case, how can we determine if two fractions are equivalent? Well, let's zoom in here. I'm doing here. Sorry. Let's see how we can determine if two fractions are equivalent. So, let's take 6 over 21 and 12 over 42. Well, we got some even numbers there, we got an odd number there. It's kind of fishy. Might not know if these are equivalent or not, but they are. And how can you determine? There's two ways, and thankfully, in math, there's usually more than one way to solve a problem. Pick which way is safest and most effective for you. Here's the two ways. Number one, go back to the lesson we just did and multiply this fraction times a number. Now, the cool thing is you should know what you multiply. You should know what you multiply 6 by to get 12, right? Multiply 6 times 2. And this has to be the same number on the top and bottom. So is 21 times 2 equal to 42? Yes. So 6 over 21 and 12 over 42, they are equivalent. Let's do 3 over 8 and 9 over 16. Kind of the same game here. Is there something we can multiply to get the number to the right? Is there something we can multiply 3 by to get 9? Why, yes, there is. It's 3. 3 times 3 is 9. Is there something we can multiply 8 by to get 16? There sure is. It's 2. But look at there. Look at there. What do we have here? We have 3 over 2. Number one, it breaks the rule that if you're going to multiply it by 1, and that 1's going to be a fraction, the same number has to be on top and bottom. 2 divided by 2, 2 books for 2 people is 1 book each, 1. 3 divided by 2 is 1.5. So we did not multiply this thing times 1, we multiplied it times 1.5, and therefore 3/8 and 9/16 are not equivalent. They are not equivalent, not equal. Dig that? So, we got a little time here. We're only 20 minutes in. This is going to be a short lesson. And I'm going to tear the band-aid off right now, 7th graders. A lot of the lessons are going to be about the size of a classroom. You have the benefit of fast forwarding and skipping around, or you can take in the whole lesson. I would ask, first day of school, I'm going to tell you what I told students on the first day of school. Have a notebook. Take notes of what I'm doing here. Write down what I'm doing here, and I'll do my best to explain it. Have your parents get in touch with me if there's anything you didn't understand, and I'll clarify for you in person, like a real YouTuber. But see if you can try this one. We're going to do 4 over 11. Is that equivalent to 12 over 35? I'm going to erase everything else while you, include the 4. I'm going to erase everything else while you work on it. Is 4 over 11 equal to 12 over 35? First thing, we're going to try to find a fraction here that's going to equal 1, which means it's going to be the same number over itself. Now, why do I use the letter A when I'm saying a number? This is the crux of algebra. In algebra, if it doesn't matter or you don't care what number it is, or if it could be any number, if I said any number and I did, if you divide any number by itself, the answer is 1. How many numbers could you write? 1 divided by 1, 8 divided by 8, 22 divided by 22, 99 divided by 99. If all of the numbers fit, Instead of using all numbers, just use the letter A, which I use to stand for all numbers. Right? If all numbers divided by all numbers equal 1, then we should be looking for a fraction down here with the same number at the top, numerator, and bottom, denominator. So, is there something we could multiply 4 by to equal 12? Well, I believe that would be 3. 4 times 3 is 12. Is there something you can multiply 11 by to equal 35? Well, let's see. 11 times 1 is 11. Times 2 is 22. Times 3 is 33. Makes sense, right? And times 4 is 44, but we're out of bounds here. It's op territory because the number was 35. So 44 is too much. And none of these numbers is 35. So the answer is no, there isn't a number you can multiply 11 by to equal 35. And 3 over x is definitely not 1. So 4 over 11 is not equal to 12 over 35. Now, what's the other way? You can take a calculator. You can take a calculator, and I'm going to do that here. I'm not going to spend too much time on it. You can take a calculator and divide 4 by 11, which is a weird thing. It repeats. 4 divided by 11 is 0.363636. And you're going to write the numbers 3 and 6, 3 and 6 until you run out of ink, pencils, crayons, paint, magic marker, sticks in the dirt, online. You will write 3, 6 forever. It never ends. And then 12 divided by 35. And this is basically just 0.36. You put a line right over that. And that equals 36363636. Now, 12 divided by 35 is 0.34287. So you can see on and I'll get rid of all the stuff here so you can see compare the dust. Oh, got rid of all of it, didn't I? So you see by the decimals here, that's 4 over 11, not equal to 12 over 35. This was 0.363636. This is 0.342857. Obviously, not equal. So that's the two ways you can determine if two fractions are equivalent. You can look at one of the numbers in the fraction and see if you can multiply it by a number to equal the other number in the second fraction. And we're talking about top and bottom. So let me use the nomenclature. Find a numerator, one of the two numerators in the two fractions. See if you can multiply that numerator by any number so it can equal the other numerator. All right? We did 2 over 4 and multiplied it times 2 over 2, and multiply those two numerators and a new numerator. Multiply those two denominators and a new denominator. Is there something you can multiply this by to equal 4? Yes. Is there something you can multiply this by to equal 8? Yes. Is it the same number? Yes. Then these two fractions are equivalent. Is there something you can multiply 4 by to equal 12? Yes. 3. There's something you can multiply 11 by to equal 35? No. 3 over question mark is definitely not equal. And you can see that by doing my guess and check with the fraction that equals 1, and 3 over question mark definitely doesn't equal 1. If you have $3 for an unknown amount of people, well, the only way that could be 1 is if it's 3, but we don't know how many people it is, so it's wrong. And we actually hacked and slashed it with the calculator and saw that numerically it doesn't ride either. So that's equivalent fractions for you. Just a quick little lesson to get back into the uploading process and all that. Hope you all had a great first day of school. This stuff is here if you need it. It's supplementary to what the teachers are teaching you. Pay attention, take notes. Don't take this subject for granted. And remember, if you had me in class, and I said it 130,000 times, this is 130,001, and I bought into it wholeheartedly. Four little bitty words. You can do it. See you later. All right. Just a little lesson to get started into it. Like I said in the video, I hate to tell you this. I know we're in a society where we want it quickly in a microwave society, but most of the videos are going to be between 30 and 40 minutes, depending on what we're working on. I'll do my best to keep it under 30 like this one, but most of them won't be. You can go forward and go back, pick spots, and get what you can get from it. Get in touch with me. Have your parents get in touch with me if you need help. Um, take notes on the first day of school. Do the best you can. You just been off for 90 days. Do the best you can. If you pass the first semester with A's, you can pretty much lock up passing the whole year. That don't mean just slack off the whole way, but Um, all that being said, I'm going to try to find some test questions, and when test time comes running around, I'm going to make little videos in another playlist called Alternative Math, and it will show you test taking tips. It'll have the story question and 4 or 5 answers, and will show you how to get rid of incredibly erroneous answers, wrong answers, and bring your, if you're guessing, bring your probability of getting it right from 1 in 4 to 1 in 2. And maybe, just maybe, even 1 out of 1, which means you will be correct. I hope you all had a great first day of school. Eighth graders are up next with their next standard. Get in touch with me. I'm going to put my email address down in the corner. Maybe down in the corner. So have your parents get in touch with me if you need help with this. Once it comes up, it might not be the first thing your teachers do. Now, it should be. It should be the second. But if it isn't, it'll be here for you in the playlist. If it is, and your teacher is going by the standards, the first one was on numbers, what type of numbers there are. That video has been out since July. Numbers in the box. There's 5 boxes. 4 of the boxes are inside each other. That's all I want to tell you about it. Check that video out if you need help with that first standard. Again, I'm available if you need me. Please like it and tell your friends about it. Tell your enemies about it. Tell everybody about it. If anybody needs help with math, and that's students 6 through 12, but it's for anybody because the alternative math, even though I do test questions, and I've got a few videos in there, one with my granddaughter and all that, it's for anybody. Alternative math is for anybody. So, all that being said, it's nice to get behind the mic. I got it with me. Got the mic. Everything's fine now. Uh, and it might be a while till I get back to 7th grade. So I'll let you know what the grade or what the discipline is at the start of each video. That's about it. You all take care. Remember, you can do it, and above all else, because it does. See you in the next one.